Good afternoon, brothers and sisters. It is 1:35 p.m. Central Standard Time on March the 2nd, 2022. I hope our Creator is keeping you well and safe wherever you are in the world. Please make sure you hit that like button and subscribe to the channel if you're new, and share this with as many platforms as you can. We are starting to ramp up, brothers and sisters. The other day I let you guys know that our baseline, how we're down here in a B2, and how we're slowly starting to get up in our baseline. And I even showed you guys how it was down here, and now it's kind of going up, and then we're going to start getting bigger flares. Well, here we go. We just popped off with an M2.02 just like not even an hour ago. Actually, it might be just barely an hour ago. And if you see how sharp it came up like this and then shot back down, that means it is a very powerful, very fast moving M flare versus this C flare here. You can see how it's kind of a slow, long, drawn out flare. That means there could be a lot of plasma with this one. This thing here obviously had quite a bit of plasma with it as it was coming off, but this one here, this was a quick pow, and we are going to break this down and see if we can't get a better look at it here in just a moment. We started off over on spaceweatherlive.com, I believe. Yeah, spaceweatherlive.com, and now we're at Space Weather Prediction Center. Our KP index is doing good, but this is what we're here to look at right over here. Oh my goodness gracious, people are blowing me up today. I've been trying to get this video done for a while. I've been on the phone. I've had so much stuff coming in, folks. It's insane. And some of it I can't. The sad thing is that some of it I can't even produce a video. I had a video striked out on me. Gave a little warning, and all my stuff came from it was all fact checked. It all came from like the WHO and yeah, all kinds of other crap. And they're like, nope, sorry. And I'm like, it does follow your guidelines. It's release stuff from the big professionals, but whatever. Anyway. Luckily, it was a warning and not a week off strike. So anyway, here we are here. This is our M flare, M2.02, and it came back down, but you can notice how we're still in the Bs. Okay, we're still up here living in B. This is our baseline. Okay, and this is what I mean by our baseline. It's all the way down here, and it comes up. We still have our strange dips, but let's go see where it came from over here. This is we're actually coming here to look at our M flare. We want to see where that baby came from. So I can hit play like that. Play. Okay, never mind. I gotta hit play there. Oh, there it is. Nice. So we can see that's actually pretty powerful one, and because you can see it actually messes with the filaments down here. It's a solar tsunami. You can see the wave going across the surface of the sun. So this definitely had some power, and there's going to be some plasma with it. We're going to have to go check it out on the Solar Dynamic Observatory. We'll have to go over to ISWA and take a peek at it. And back over here at spaceweatherlive.com, looking at SDO, we are actually currently looking at our HMI magnetogram. God dang, I can't even speak. And I would have thought maybe, just from looking at this, you would think it would come maybe from here, because this is getting kind of complex, and yeah, this is a pretty close friend. So there's going to be some more stuff coming out of this right here, folks. And if you look at here, you got two other small ones that are starting to form. So that's going to get a sunspot name, I think. So we're going to need to keep our eye on that one there. And it looks like we got a positive here, and it looks like we might have a couple of small negatives possibly popping up. So this whole thing right here could wind up getting crazy on us. But this is where we had our pop-off right here. And it's kind of difficult to see this. I mean, they put the numbers right over top of the freaking holes. It's like, dude, we can't see the umbras. What the heck? But anyways, looking over here at 2955. Ooh, it's looking like it's got a friend to play with over here, and this could be a crazy week, folks. It's getting pretty nutty. Now, as we move over here to our Space Weather Enthusiast dashboard, which is one of my favorite places to go here when we're on Space Weather Prediction Center, we can obviously see our M flare here, our dips that we've been having recently at the same time every day. Looks like we got 1s and 2s and a couple of 3s here for our KP over the next couple of days. And we're going to scroll and mosey in. Here's our sunspots. Yeah. These two and these two. Yeah. Because you got blue and red and blue and red. So, yeah, these could wind up playing together, and that could cause one heck of a mess. But let's scroll on down here. Look at our Ace Mag and Sweep Ham. Looks like it's like going all over the place. I don't know why, or it's being turned off. Either way, it seems to come back on completely balanced like, oh, everything's normal. I don't know about that. Seems a little hokey pokey to me, but whatever. And this right here is our M flare that we just got hammered with. Kind of back up a little bit, and as we come into it, you can see about 1734 is when she starts off, and we did get up to 30 decibels for a good 3 minutes, and then she slowly starts to come down. So it wasn't, like I said, it was not a very long-term event, you know, the peak of it, but it definitely, that's it right there, yeah, about 1740, about 3 minutes worth of the peak. So either way, that's a lot. I mean, look at how much area really covered. Let's get to the peak of it. Okay, right here. You're looking at a minimum of 20 meters cubed, or excuse me, 20 decibels from Antarctica all the way here, from this point, all the way up here into the Hudson Bay area of Canada. This whole region had 20 decibels. Think about that. That's a lot of X-ray. And that X-ray was for, oh, let's say 36. Yeah, about 20 minutes of just hard, raw, unfiltered X-ray. Yippee-ki-yay. And here we are looking at our Italian model for the Schumann resonance. And if you look here, I almost see like a pattern here between 6 in the morning and 6 in the evening. So you got a 12-hour span, right? It was where most of the activity comes in. You see that? I almost wonder if there's like some kind of an algorithm for it to do this. I mean, it just seems kind of funky. Now this is UTC time, by the way, folks, okay? And if you look here on the 28th, it did kind of start popping off at nighttime and carried all the way up and then stopped, and then it got back into a normal pattern. Do you see that? This is interesting. Let's check out Russia. And Russia, yeah, we definitely got something going on here. Where are we at? Power of 38? Yeah, we're peaking out pretty high today. We've definitely got some stuff going on. This is a lot of activity. This especially, that's a lot of noise going on right there. Well, let's go on over here and check out space weather. This is going to be fun for you guys. It's called a termination event. Here's a little bit of education for us, okay? Right here, and I know that I've shown this to you guys before, where they've shown us the sunspots. The predicted sunspots and the activity, you know, versus, you know, what they predicted and what we're actually having. So this blue line is the prediction model. Okay, this is their prediction line or panel, okay? But this red one is their new modified prediction model. Look at how high now this is supposed to be a minimum. Okay, this is supposed to be a solar cycle 25, which is supposed to be a minimum one, which is why they projected it for being less than this guy. But look at it now. Yo. Yeah, it's projected to be pretty much even with this one, with the possibility of it being here. Yeah, I think it's going to be more like up here, my personal opinion. But anyways, we are here at spaceweather.com. You can come over and take a peek at it. Termination event has arrived, which is really what they're calling it. Something big just happened on the sun. Solar physicists Scott McIntosh and Bob Lehman call it the termination event, which it is really what it is. The termination event is a new idea in solar physics outlined by McIntosh and Lehman in the journal Solar Physics. Not everyone accepts it yet, though. But if solar cycle 25 unfolds as McIntosh and Lehman predict, the termination event will have to be taken seriously. And basically what it is, and I don't know if they're going to show it. Yeah, they're not going to show a graph on it. Okay, so, you know what? I can show you. Hold on just a second. Okay, this right here is a GIF that is of our current solar cycle 25 termination event. And I've actually spoken about this before, where the North Pole of our sun will send off a positive energy, basically magnetic pole, a magnetic charge, you know, positive magnetism towards the equator. The South Pole sends off a south charge, you know, a negative charge towards the equator. And they meet in the middle, okay, positive and negative, they meet in the middle and cancel each other out. Okay, but then it switches, and the North Pole sends out a negative magnetic charge towards the equator, and the South Pole sends out a positive charge, magnetic charge to the equator. So you see it changing color. It goes from blue to red, and then red to blue, blue to red, red to blue. It does this every 11 years. It is a cycle that they've been finding going on, and it's been going back for years, which is how they're able to use it as some kind of a prediction model. Even though it can do anything it wants, it kind of helps us to regulate, to get an idea. Okay? So what's been happening here is that solar cycle 25 started in December of 2019. Okay, however, old solar cycle 24 was like refusing to go away. It just kind of kept hanging on. Okay, it was kind of difficult. It wasn't like a smooth transition. So it hung on for 2 more years, producing occasional old cycle sunspots and clogging the sun's upper layers with its decaying magnetic field. During this time, the two cycles coexisted, with solar cycle 25 struggling to break free while old solar cycle 24 was still holding it back. Basically, 24 was cramping 25 style. Researchers have long known that solar cycles can overlap. The twist added by McIntosh and Lehman is the realization that overlapping cycles can interact, which makes sense. In the early 20th century, George Elliott Hale discovered that the magnetic polarity of sunspot pairs reverses itself from one cycle to the next. Indeed, the sun's entire global magnetic field flips every 11 years. When adjacent opposite polarity solar cycles overlap, they naturally interfere. Termination events mark the end of the interference, when a new cycle can break free of the old. You know, I find it kind of funny that, you know, we're over here talking about that, and they have Terminator right here. Don't we have like a Skynet up there right now, or a Starlink? Same thing. Didn't we go over that already? In our face almost, right? So, the timing of the termination event can predict the intensity of the new solar cycle in their solar physics paper. When they looked back over 270 years of sunspot data and found the termination events happened every 10 to 15 years, with 11 years being the average. So basically, we are having if we have a longer time between terminators, it means the weaker the next cycle will be. Okay, but if they're shorter in between terminators, the stronger the next solar cycle is going to be, and so it can continue to ramp up and get bigger and bigger, you know, with every cycle. And as we've already shown, with the new forecast, this was NOAA's, and with the new information, the new data, we are predicting to be way up here. This is their line of prediction, but it can be from here to here. So, yippee-ki-yay. Now we are over here at IS-1. We're looking at the 304, and I'm not really seeing any major filament disruptions, or releases, should I say. Nothing significant on the 304. I mean, there's going to be some plasma with every one of these flares. You're going to have little bits of coronal mass ejection. I mean, it's just going to happen, but it may not be a major event. We've only got a couple of minutes here, so I'm going to try and get through these. And this is our 193, where we should really be... Yeah, okay, yep. See that in the lower left right there? Yep, definitely got some plasma coming off of that. Little filament off of there. Oh, top right. Right there, we got a little bloop right there. And then, of course, yeah, there's our M flare. And we can see it totally disrupting the surface of the sun. A little solar tsunami. So, yeah, we definitely have some coming in. Plus, not to mention, we've also got our coronal holes that are facing us. So, anything that got pushed out, it kind of hitched a little ride, stuck out its thumb, and hitched a ride with the solar winds from the coronal hole. So, let's take a peek here at our 94. And let's see, let's just back it up a little bit. Ooh, okay, so we can see our flares that were coming off from the backside. So, all we got from those was X-rays over the last couple of days. And let's kind of start going up a little bit with it, see if we can manage to see any. Yep, okay, yep. So, right here, this is our long-term event CFUN. You can kind of see it swooshing off. So, we do have some plasma coming out of that. Not a whole bunch of it, though, but there is some. And then there's some in the top right. Not a whole lot, but you can see the movement. And then the X flare, and really the M flare. The M flare looks like it's just a heavy hitting M flare. There's not really a lot of plasma. So, anyways, I'll keep my eyes open, folks. Remember, let's all keep our eyes open, right? No fear, and remember that love is the only way forward.